Hello, welcome to Advanced Composites. Today is the fourth day of the ongoing week, which is the 7th week of this course. And yesterday we started a new problem, that is case E, in which we had a semi-infinite plate in the x direction, and this plate is unsymmetric in nature. One of its ends is pinned and fixed, and the other end is pinned but on roller supports, and such a plate is being subjected to an in-plane force, and the force resultant in the x direction is uniform externally applied force resultant is n bar. So, with that problem formulation, what we have done till so far is we have come up with an expression for W naught x, which is this entire relation. And now what we plan to do is we want to evaluate the value of these integration constants C6, C5 and C8 from W naught x, and then later we will also use the same thing and compute the relation for U naught. So, the boundary conditions for this plate, the ones which are checked in red, we have already applied. We will now apply two boundary conditions, and these two boundary conditions are on W naught. And let us see that once we apply these two boundary conditions, what does the relation for W naught come out as. So, apply BC, and the boundary condition is that W naught is equal to 0 at x is equal to plus minus a over 2. So, what that means is that, so if I apply at x is equal to a over 2, what do I get? I get 0 equals this entire thing times a over 2 minus n bar a square over 8 plus C8, and if we apply the other boundary condition x is equal to minus a over 2, I get this same parameter, but here I have a negative times a over 2 minus n bar a square over 8 plus C8. Okay. So, we have two equations, one for a over 2, one for negative a over 2. If I add them, or if I add them, then I get C8 is equal to n bar a square over 8 if I add these boundary conditions, and if I subtract them, I get this entire parameter in the expression, this a11 over b11 times C6 minus C5, this is equal to 0, right. So, once I get this, I can say that W naught over x is equal to n bar a square over 8 minus n bar x square over 2 into b11 by b11 minus a11 d11, this b11 square, this is my expression. Okay. And I can just reorganize this again. So, if I have to reorganize it, what I am going to do is I am going to take n a square over 2 outside the bracket to and I will call a11, also I will take it out, and this is script d11 and in the parenthesis I will be left with is 1 over 4 minus x over a square, and here d11 is equal to d11 minus b11 square over a11. This d11 script. So, this is the same definition which we have used earlier. So, we once again see that in the denominator we do not get d11 for a unsymmetric laminate, rather we get this d11 script, and we had said earlier that this is known as reduced bending stiffness, and essentially what it means is that the stiffness of this plate, it gets reduced because of the presence of B11. If B11 was not there, then the plate would be more stiff, and it diminishes because of the presence of B11. Okay. So, this is the expression for D11. So, there is one small, actually the sign here was incorrect. So, I will fix that. So, this is x over a whole square minus 1 over 4. This is there. So, this is the expression for W naught x, and if you now go back, so now you can compute dW dx from here, and you plug the value of dW over dx in the expression for u naught. You can plug it in one of these equations. So, you can plug it in here, okay. And once you plug it in, so what I am saying is, so now compute dW naught over dx and put it back in equation 2 to find u naught x. So, that is a simple mathematical process, and then apply the boundary condition. So, which boundary condition we use? We use u naught is equal to 0 at x is equal to minus a by 2, and then what you end up getting is u naught is equal to 1 plus b11 square over a11 d11 script into n over a11 n bar times x plus a over 2. So, this is the expression for u naught, and the expression for v naught is 0. So, now we have solved this problem. Okay. So, we have an expression for u naught, v naught and w naught. Now, we will make some observations here. So, one thing I omitted accidentally in the expression for w naught is that there is a b11 here, but I omitted it here. So, this b11 should have been here. So, that is a error which you guys should note. So, we will make some observations. The first thing is that at x is equal to 0, which is at the mid of the plate, let us compute the value of w naught. So, when x is equal to 0, w naught at 0 equals n bar a square b11 divided by 2 a11 d11 into, and there is a negative sign, times 1 by 4. Okay. So, in this case once again we see that depending on the sign of B11, W naught will be either positive or negative. So, what that means is that if B11 is greater than 0 and our original plate is like this. So, when it is greater than 0, it means what? That the 90 degrees ply are, this is 90 and this is 0, then B11 is greater than 0. We had computed the value of B11. Huh? So, if that is the case and if B11 is greater than 0, and of course, n bar is positive, n bar is positive, a square is positive, a11 is positive, d11 is positive, everything is positive. Then if B11 is greater than 0, then the plate will bend in which direction? The plate will exhibit a negative deflection, which means it will bend. So, it will bend something like this. Why is it going to bend in the, we are saying it is going to bend in the negative direction because in our entire coordinate system, this is x and this is z. Z is always downwards. If you remember, throughout our coordinate system, when we calculated ABD matrices and we developed the relation that epsilon x is equal to epsilon x naught minus zkx, in this z axis was always going down from the midplane. Okay. So, if it goes down, then it would be considered a positive displacement, but it has to be negative. We are saying because B11 is positive, n bar is positive, a square is positive, but there is a negative sign here, and because there is a negative sign, it means that the midplane deflection of the plate is going to be negative, which means it is going to bend upwards. Okay. It is going to bend upwards, and if B11 is less than 0, so if it is less than 0, then the plate configuration will be something like this, 0 on top and 90 on the bottom, and in this case the plate will bend something like this. So, the first interesting thing is that what is the problem? The problem is that we are subjecting a flat plate to a tensile load, and normally you would not expect the plate to bend, it would only get stretched, but because of the presence of B matrix, the plate bends, and so that is the first thing, because of the presence of B matrix, and the direction of the plate bending is determined by B11 in this case. So, this is mathematically how it works out. The physical reason why plate bends in this case upwards and in the second case when B11 is less than 0 is because, okay, so so the physical reason. Physical explanation. For direction of plate bending. In both the cases, we note bending is more on or in 90-degree ply, right? It is more in 90-degree ply. Why do I say that? Consider this case. So, consider the case B11 is more than 0. If B11 is more than 0, the plate configuration is like this. You have 90-degree on top and 0 on bottom, and when it bends, it is bending like this. So, 90 is on top and 0 is on the bottom, which means there is more stretching happening on the 90 degree ply, right, because it has and there is less stretching happening in the 0 degree ply, and that makes sense because 0 degree ply is stiffer in the x direction. Its EL in the Ex for 0 degree ply is very large compared to Ex for 90 degree ply. Okay. So, it stretches in the, so it tries to stretch less, and 90 degree ply tries to stretch more because it is more compliant. And the same thing happens when B11 is less than 0. What happens? The order of the lamination sequence, it reverses. So, in this case the plate bends like this. So, once again 0 degree ply is on the inside and 90 degree ply is on the outside. Once again here also the 90 degree ply stretches more and 0 degree ply stretches less. Okay. So, this is the physical reason why B11 influences the direction, because it provides some kind of preference to less stiff plies and less preference to more stiff plies. So, that is the role of B11. So, this is what I wanted to discuss today. Tomorrow onwards, which is the next 2 lectures, we will venture into a new area of this course, and we will start discussing thermal stresses and thermal strains in context of laminated composite plates. So, we will learn how to handle thermal stresses and thermal strains, and whatever we are going to discuss tomorrow and maybe a day after tomorrow onwards, that is not only applicable for composite plates, but it is also going to be applicable for plates with isotropic materials if they are made up of several layers and each layer is having a different material. So, that is what we plan to start discussing tomorrow onwards. Thank you, and I look forward to seeing you tomorrow. Bye.